Well, hello everybody, and welcome back to another episode of Maths. In the last video, we discussed how to add and subtract mixed numbers together, and we also discussed how to add mixed numbers with improper fractions and how to subtract them with each other, so kind of mixing them up a little bit. And today we're going to be practicing that to get used to the topic a little bit more. And these are kind of nice questions because they kind of really test our knowledge on a lot of the things we've been doing with fractions. They test us how to convert between mixed numbers and improper fractions. They test us on how to, add fractions and how to subtract them. They test us on how to simplify fractions, right? How to find a common denominator, all that stuff, right? So these are really good kind of testing questions where you have to know all your fraction stuff really solid up to this point. So let's go ahead. You try these problems out for yourself first, of course, and then we will try them together. All right, so question 1. We have 3 and 13 over 24, and we're adding it to 4 and 1/6. And we're supposed to compute this sum, and we need to make sure our answer is a mixed number when we're done here. So there were two methods to add mixed numbers. For this one, I'm going to do both of the methods, but then I'm going to stick with method 2 for the rest of the sheet for the most part, just because that's the one I prefer. And I think that one's overall usually the better one to go about, but both methods work, and sometimes some methods are a little faster than the other. So let's start with method 1 for this. So that's basically we add the whole number components, so 3 and 4. 3 plus 4 is 7. And then we deal with the fraction pieces. So we're looking at 13 over 24 plus 1 over 6. So we note that 6 is a factor of 24. So we can simply just multiply it by whatever we need to make it into 24, which is by 4, right? So we get our common denominator is a nice 24. So this becomes 13 over 24 plus 4 over 24, which is 17 over 24. And that is the fraction piece, and we're done. All right, so that was nice and quick. So method 1 actually was pretty nice for this problem. That's not always the case, especially when we end up getting like an improper fraction here, then there's kind of a lot more steps, which is why I usually like the second method. But let's do the second method for this one as well, and we'll get the same thing. So we do 3 and 13 over 24 plus 4 and 1 over 6. Okay. All right, I made a little mistake here, so just ignore that. So if we do 24 times 3, that'll be 72, plus 13 will be 85. All right, so we're going to get 85 here. And then if we do, and that's going to be out of 24. And then if we do 4 times 6 is 24, plus 1 is 25. And that's going to be still out of 6 like that. So now we need to make a common denominator. Just like up here, we just multiply it by 4 each, right? Because 6 times 4 is 24. So that'll give us our common denominator. So we have 85 over 24. 25 times 4 is 100. So plus 100 over 24. And that gives us 185 over 24. So we could go ahead and try and simplify this, but we're going to have to divide it anyways when we're converting it into a mixed number. So let's do that first. So 185 divided by 24. Okay, so how many times does 24 go into 1? It doesn't. How about 18? It doesn't either. So we have to look at how many times 24 goes into 185. So we might have to multiply it by a few numbers to figure out what the best one is, since it's getting kind of big now. So let's try, I'm thinking maybe 7, since 2 times 7 is 14, so 20 times 7 will be 140, and then we'll just have a little bit more. So let's try 24 times 7. Okay, so 7 times 4 is 28, and 7 times 2 is 14. Add that carry of a 2, we get 168. If I try to add another 24 in there, I'm going to be at 192, so that's a bit too big. So we can only go in 7 times, and that'll be 168. So then we'll subtract that off, which will be 17, and we're already done, right? So we get then that 185 over 24 is 7, and then our remainder is 17 over 24. And we get the same thing we had up here, right? So admittedly, method 2 was a bit longer and had some more complex numbers involved. So again, it's good to actually get used to both methods, and then maybe you can start to kind of recognize which is going to be faster and which is going to be slower. But let's go on to part B now. And again, we're going to be mostly sticking with the method I mostly focused on in the video, which was just converting them into improper fractions and then converting them back afterwards. All right, so if we do 12 and 1/5, and we add it to 10 and 2/3, let's start by converting them into improper fractions. So we do 12 times 5, which is 60, plus 1 is 61 over 5. And then we have 3 times 10 plus 2, so that's 32 over 3. Okay, so to make a common denominator, the common denominator will be 15, right? Since 5 and 3 are coprime with each other, so their lowest common multiple is just their product, which is 15. So we multiply this by 3 on the numerator and denominator, and this fraction by 5 on the numerator and denominator, and that'll give us 183 over 15 plus 160 over 15. All right, so you can check my numbers there if you'd like. And we have our common denominator now, so we can just add our numerators, which will become 343 over 15. All right, so now we have a fraction, we can just convert it into a mixed number. So we have 343 divided by 15. 15 goes into 3 no times, but it goes into 34 twice, right? 2 times 15 is 30. Subtract that off, we get a 4. Bring down the 3. How many times does 15 go into 43? Once again, it's only twice, right? Because if we try and add another 15 to 30, we get 45, which is too big. So we have 15 times 2 is 30. Subtract it off, we get a remainder of 13. So this ends up being 22 and 13 over 15. So that's not too bad. And let's go on to part C. So we have -3 and 5/6 plus 5/4. So this was a mixed number plus an improper fraction. And this is also where it's kind of nice to be using the second method, because if we convert this into an improper fraction, right, then we're just kind of ready to go already because we already have an improper fraction here. So if we do that, we have 3 times 6, which is 18, plus 5 is 23. So we get 23 over 6, but it's a negative, right? So we need to make sure we're doing -23 over 6. And then we're adding 5/4 to this. Okay, so we need to make a common denominator. So the lowest common multiple of 6 and 4. What's that going to be? Well, 6, that is 2 times 3. And 4, that is 2 times 2. So the lowest common multiple will be 2 times 2 to cover the 4. And then we also need the 3 and the 6 to make that covered. So that's going to be 12. So our common denominator is going to be 12. So I'm going to multiply these each by 2. And I'm going to multiply these each by 3. And that is going to give us -46 over 12 plus 15 over 12, which is going to be, let's see, -31 over 12. All right, and now we just need to convert that into a mixed number, right? Because the question is asking us to. All right, so if we do 31 divided by 12, again, we'll ignore the negative because we can put that in after. 12 goes into 31 twice, right? 2 times 12 is 24. Going more than that, we pass 31. So 31 minus 24 is 7. So we get 2, and our remainder is 7 over 12. But once again, it's negative, right? Because a negative divided by positive is negative. So that is going to be our answer right there. And if you want some extra practice, make your own mixed numbers and improper fractions and compute their sums. Make sure some of them are negative, some of them are positive, just for a bit more variety in there. And again, try and use both method 1 and method 2. See which one you like more. Again, I prefer method 2, but it's kind of up to you. So let's go on to question 2. All right, so question 2 says, compute the following differences and express your answer as a mixed number. So this is virtually the same as question 1, except we're just doing some subtraction. But the technique is pretty well the same, so you're going to get a lot of practice with that today. All right, so let's convert these into improper fractions. So 2 times 4 is 8, plus 1 is 9. So this first one is 9/4. And then we're subtracting. 10 times 7 is 70, plus 3 is 73. So we're subtracting 73 over 7. The common denominator is going to be 28, since 4 times 7 is 28, and we're multiplying them because that's the lowest common multiple of these two numbers since they're coprime. Right, so we're going to be multiplying the numerator and denominator of this one by 7 and this fraction with 4. Okay, so 9 times 7, that's 63 over 28. And 73 times 4, might not be able to do that in our heads, so let's do that over on the side here. 3 times 4 is 12. 7 times 4 is 28, plus 1 is 29. So we get 292. So we have 63 minus 292 over 28. All right. So how do we do this? Well, this is just 63 minus 292 over 28. And at some point when you were learning how to add and subtract numbers, you will have hopefully learned this trick where if you're doing a smaller number minus a bigger number, you can actually just do it the other way around where we do 292 minus 63. So then we'll borrow a 1 from this 9 here, so that gives us a 12. 12 minus 3 is 9. 8 minus 6 is 2, and we get 229. But since we flipped it here, we have to put the negative back in, which makes sense since we're subtracting a bigger thing from a smaller thing. So we get negative 229. So that means our answer up here is going to be negative 229, all divided by 28. So if you haven't learned that trick before, it's a pretty useful one where you just kind of flip them, do the subtraction, and then put the negative back where it belongs. So keep that in mind if you didn't know that little trick there. So now we have this, and we got to put it as a mixed number, right? So let's do 229, and we're dividing it by 28. And again, we'll put the negative in afterwards. So 28 can't go into 2 nor 22. So unfortunately, we have to see how many times it goes into 229 in its entirety. So you can guess and check some numbers, but I think 8 might be the one that does it. So if we do 28 times 8, 8 times 8 is 64. And then 8 times 2 is 16, plus the carry of 6, we get 22. So 224 is 8 times 28, and that's really close to 229, right? So yeah, it's looking like 8's going to be the one that does it. 8 times 28, 224. Subtract that off, we get a remainder of 5. So what this ends up becoming is 8, right? That's the quotient, and then 5 is our remainder over 28, and we have to put the negative in, so we get negative 8 and 5 over 28. Okay, that's part A. Let's move on to part B here. So we got 1,004 over 3 minus 102/9. Okay, so this is already an improper fraction, but we got to convert this mixed number into an improper fraction. So we will multiply 100 by 9, which is 900, add the 2, so that becomes 902. So this is 1,004 over 3 minus 902 divided by 9. So now we need to make a common denominator. 3 is a multiple of 9 though, right? So we can just multiply the numerator and denominator of 1,004 over 3 by 3 each. And that'll give us 3,012 over 9 minus 902 over 9. Okay, we can do 3,012 minus 902. That should be 2,110. Divide that by 9. And now we can just do division to convert this back into a mixed number. So 9 goes into 21 twice, subtract off the 18, we get a 3. Bring down the 1. All right, how many times does 9 go into 31? It goes in 3 times, since 3 times 9 is 27. Subtract it off, we get 4 remaining. Bring down the 0. 9 goes into 40 4 times. 4 times 9 is 36. Subtract that off, we get a remainder of 4. So this is going to be 234, that's our quotient, and then our remainder is 4 over 9. So that right there is your answer to this problem. Big numbers, that's all right, same process. And let's do part C here. Negative 1 and 2/15 minus 7 over 6. Okay, once again, convert this into an improper fraction. So we have 1 times 15 is 15, plus the 2 is 17. Can't forget the negative up front though, so this becomes negative 17 over 15 minus 7 over 6. So we want to find the lowest common multiple of 15 and 6 to find our common denominator, our optimal common denominator. All right, so computing the lowest common multiple, we find 15's prime factorization is 3 times 5, 6's prime factorization is 2 times 3, so 2 times 3 times 5 will be what covers both their prime factorizations minimally, which gives us a lowest common multiple of 30, which is going to be then their common denominator. So that's the optimal common denominator for us to go for. So we will multiply these both by 2, since that'll take us to 30, and we'll multiply these both by 5 to take us to 30 in the denominator. So we're going to get negative 34 over 30 minus 7 times 5 is 35 over 30. So this becomes minus 34 minus 35. So since they're both negative, we can basically just add them and put a negative up front. So this becomes negative 69 over 30. All right. And you might notice that this can be simplified a bit. So 69 and 30 are both divisible by 3. So this is the same thing as negative 23 over 10. Okay, so now we can just convert this into a mixed number. So we'll do 23 divided by 10. 10 goes into 20 twice. 10 goes into 23 twice. Subtract off 20, we have a remainder of 3. So this becomes negative 2 and a remainder of 3 over 10. So that is the answer to that one. Okay, and for some extra practice, make your own mixed numbers and improper fractions and compute their differences. Okay, so question 3 says compute the following and express your answer as an improper fraction this time. So that's nice, we don't have to convert it back to a mixed number. All right, so we have 10 plus 3 and 4/5 minus 6 and 4/7 plus 40 over 35. Okay, so we have all of these to combine, and we have some mixed numbers, we have an improper fraction, and we also have a whole number here. But ultimately, we are probably going to want to put them all in terms of improper fractions so that we can find a common denominator and easily combine them. So to do that, first of all, we got to write 10 as just 10 over 1. So we'll have 10 over 1. And then 3 and 4/5, we can do 3 times 5, which is 15, add the 4, which is 19. So we get 19 over 5. Then we'll have to do 6 times 7 plus 4. So 6 times 7 is 42, plus 4 is 46. So we have 46 over 7, and we'll be subtracting that, right, because of the minus there. And then we have plus 40 over 35. Okay, so now everything is in terms of improper fractions. Great, so now we need to get our common denominator. So notice we have 35 here, and 5 and 7 are both factors of 35, right? So that's nice. So we're just going to basically get that 35 is going to be our common denominator here. So to get 10 over 1 to a denominator of 35, we have to multiply the numerator and denominator by 35 each. To get 19 over 5 to our common denominator of 35, we got to multiply by 7 each. And here we got to multiply by 5 each, right? Since 7 times 5 is 35. All right, so now we just got a ton of multiplication to do. So 10 times 35, that's 350, right? Anything times 10, you just add an extra 0 at the end of it. And then we have over 35. And then we got 19 times 7. So let's do that on the side here. So 9 times 7, that's 63. So we got a 6 there, a 3 there, and 7 times 1 is 7, plus the 16, that's 133. So we get 133 over 35. And then we got to do 46 times 5. So 46 times 5, that is going to be 230, right? 5 times 6 is 30, and then 5 times 4 is 20, plus the 3 is 23, so we get 230, but we're subtracting it, right? So this is going to be 230 over 35, and then plus 40 over 35. So we can write that as 350 plus 133 minus 230 plus 40, all that over 35. So we can start with the addition. So we have 350 plus 133 plus 40. So we have 0 plus 3 plus 0 is 3. 5 plus 3 plus 4 is 12, so we'll carry the 1 up here, and 1 plus 3 plus 1 is 5. So we get 523, and then we have to subtract the 230 still, right? Because we didn't do that yet. So 523 minus 230. 3 minus 0 is 3. 2 minus 3, we'll have to borrow a 1 from the 5, so this gives us 12 minus 3 is 9, and then 4 minus 2 is 2, so we get 293. So we get 293 over 35. All right, and I'll just tell you now that's already simplified. But if you look it up, you'll find that 293 is prime, so that means this is going to be simplified. So if you want some extra practice, just combine several things now, right? Instead of just addition of two things or subtraction of two things, you can do several of them, some of them being mixed numbers, some of them being improper fractions, and some of them just being regular whole numbers. All right, let's move on to question 4. All right, so question 4 says compute the following, and we got to express our answer as an improper fraction. So we have 2 1/5 plus 1.35, so we got a decimal involved here, minus 31 over 2. So we know how to combine mixed numbers and improper fractions. We just convert the mixed number into an improper fraction and go from there. But what about this decimal? Well, if you recall, we know how to convert decimals into improper fractions, right? So to do that, what was the method? Well, we basically got rid of the decimal for the numerator, so we got 135, and we see how many times was the decimal moved over by? 1, 2 times, right? So 2, that's the power of 10, or 10 squared, right, that we'll put in the denominator, so that is going to be 100, right? 2 zeros. So 1.35 is the same as 135 divided by 100, and then we're subtracting 31 over 2. So now we just need to make this 2 and 1/5 into a improper fraction, so we'll do 2 times 5, which is 10, plus 1, which is 11. So we get 11 over 5. And then here we have 135 over 100. And then lastly, we have 31 over 2 that we're subtracting. Okay, so now we're all in terms of improper fractions, and it's go time. But before we make a common denominator, 135 and 100, these are both divisible by 5 clearly, right? This ends in a 5, that ends in a 0, so we could simplify this fraction down a bit, and that might make our job of finding a common denominator a little bit easier. So 135 divided by 5. 5 goes into 13 twice, subtract off the 10, we get a 3, bring down the 5, that's 35. 5 goes into 35 7 times, so we get 0. Alright, so that's just a quick little division there. So we have 11 over 5. So that is going to be adding to 135 divided by 5, we just saw was 27, and 100 divided by 5, that's a common one, that's 20. So we're subtracting 31 over 2. All right, so now this is nice because 5 and 2 are clearly factors of 20. So 20 is going to be our common denominator that we're looking for. So to get from 5 to 20, we have to multiply by 4, doing that to both the top and bottom to make it a equivalent fraction to 11/5. And then similarly over here, 2 times 10 will give us the 20 we need. All right, so this becomes 44 over 20. Then we have plus 27 over 20. And then we're subtracting 310 over 20, right? 31 times 10 will be 310. Okay, so this is just 44 plus 27 minus 310, all that divided by 20. 44 plus 27, that is 71. Subtracting 310. Okay, so once again, let's go back to that trick where we do the bigger one minus the smaller one. So 310 minus 71. We'll have to borrow a 1 from this 10 here. So 10 minus 1 is 9, and we'll have to borrow a carry of a 1 from this 3. So 10 minus 3, so 10 minus 7 rather, is 3, and then we have a 2. So we got 239, but because we did it the opposite order, and really we're taking a bigger number out of a smaller one, we need to put a negative in front of that 239 and dividing it by 20. 20's prime factorization is 2 times 2 times 5. So for this to simplify, basically 239 would need to have a 2 or a 5 in its prime factorization, which it doesn't because it's odd, which means it can't be divisible by 2, so that rules these out. And it doesn't end in a 0 or 5, so it can't be divisible by 5, so that rules that one out. So that means negative 239 over 20 is going to be our final answer. And if you want some bonus practice, just like the last one, just combine a bunch of numbers together, but now also introduce some decimals in there to really spice things up. And you're going to get a ton of practice that way. All right, so we're almost done. Hang in there. Let's move on to question 5. All right, so this says the lecture video introduced 2 methods for adding mixed numbers and claimed the second was the best. And again, that's not exactly true, right? We saw in question 1 that sometimes the first method is a little faster, right? So best is a little bit subjective, right? So you could put that in quotations. But explain why the first method might be better for calculating this, all right? So this is an example where the first method could be better. So let's see, we have 5 and 1/7, plus 3 and 2/7, plus 7 and 3/7, plus 1 and 4/7, plus 23 and 5/7, plus 8 and 6/7, plus 9. Okay, so why would the first method be better here? Well, if we were to convert all of these into improper fractions, that's an insane amount of work, right? We have to multiply all of these numbers and then add that, and then we're just going to have these absolutely massive numbers by the end of it, and then we're going to have to divide all those girth boys by 7 as well if we want to convert it into a mixed number. So there's just a lot of work here. But if we do the first method where we add up the whole numbers, that's relatively easy, right? 5 plus 3 is 8, plus 7 is 15, plus 1 is 16, plus 23 is 39, plus 8 is 47, plus 9 is 56, I believe. And then we just have to add up all these fractions, right? So this is 1/7 plus 2/7, and this is nice, they're all out of the same denominator, so we don't even need to make a common denominator. So we can just add the numerators. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21. So we end up getting 21 over 7 for the fractions. But 21 divided by 7 is just 3, right? So we end up getting 56 plus 3. Nice, even 59. Super easy, right? Not a lot of work involved whatsoever. But it would have been an absolute nightmare to do this with converting them all into improper fractions first. So again, kind of like I was saying earlier, you got to use a little bit of strategy with what method to use. Otherwise, you're going to be in for a world of hurt sometimes. But yeah, now we're comfortable with adding and subtracting any type of fraction whatsoever. We have a few methods to do it. And yeah, moving forward, we're going to do some more interesting stuff with fractions. So I hope you're looking forward to that. But good work today. But until the next video, you have a good one, you stay groovy, and I'll see you in that next video.